All right, let's look at the homework number 4, problem number 2. All right, so this is a water tank problem. Right, so the tank contains 1,000 liter of solution, and which contains 100 kilograms of salt already. Right, then you pour pure water, so 0 kilogram per liter, at the rate of 5 liters per second. Right, then the mixture is pumped out at the same rate, which means that this amount of water in the tank, or maybe I should say amount of the solution in the tank, will be always at 1,000. Right, the question is, how long will it be until only 10 kilogram of salt remain in the tank? All right, so we have to have some kind of function for the amount of salt in the tank. All right, so let's call x of t. All right, so let's say salt x of t, or maybe we can call it the s of t because we're talking about salt, right? So let's call it the s of t. All right, so this is the amount of salt after t seconds. So after t seconds. All right, so let's look at the rate of change of the amount of salt. So let's say ds over dt. All right, then we have to think about, okay, how much salt is added to this solution. So we have to come up with the rate in and then minus rate out. So how much salt is pumped out of the tank. So we have to look at the rate out. Right. All right, rate in is actually quite easy because you are pouring into pouring a pure water. So no salt is actually added. So this actually is 0. All right. All right, but we know that after t seconds, you're going to have s kilogram amount of salt. All right, and the amount of solution is 1,000 liter. So we know that the concentration is going to be S over 1,000, right? This is kilogram per liter. So this is a concentration at the time t. So this is S of t, right? At the 5 liters per second. So this is going to be S over 1,000 times the rate is 5 liters per second, so multiply by 5, right? So we can simplify a bit. So you have 5 and 1,000 cancel out, so that will be 200 here, right? So you would have equation. So if you clean it up, right, you have equation ds over dt is equal to, right, S over 200. All right, and luckily this is something you can work with because this is a separable equation. Right, then initial condition would be so you have S of say 0. All right, initially this guy is containing 100 kilograms of salt. So you can think of this problem as solving this initial value problem. All right, once you found S of t, then to answer the actual question, we have to set the S of t equals 1 out 10, then solve for this equation for T. Right? That will get you the answer that you're looking for. Right? That's it. I hope that this will get you going.